Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.
Hello everyone, welcome to room 1, session 3. In this session we're going to have a second presentation. We'd like to start by our first presenter, Dr. Dikay, going to be presenting the paper titled Middle East Water Resources and Turkey. Dikay Hoca, hoş geldiniz.
Evet.
Welcome.
Thank you.
Mic is yours.
Okay. Good afternoon to everybody. I would like to thank the organizing committee for inviting me to present a paper. The title is Middle East Water Resources and Turkey. Now, first of all, of course, the water resources are not only significant for Middle East and my country. Of course, it is the source of sustainable. It is necessary for sustainability of life. Now, if I go to the next slide, let us look at the map of Middle East. First of all, if you look at this map, of course, the yellow, these open yellow sort of countries, these are regarded as Middle East countries. So far as the Turkey is concerned, it is at the very north. So that means it is rather in between equator and the northern polar. And whenever we look to Sudan and Yemen in the south, and they are very close to equator. Why I'm saying this? Because so far as Turkey is concerned, of course, it is very rugged country, especially the eastern part of Turkey. There are a lot of rainfalls and along the Black Sea, as well as the snow on these days, especially. And therefore, the water resources of Turkey is dependent on rainfall regime, as well as the snow during the winter time. But when we go to the side of to the south, in that case, the water resources are also dependent on topography as well as the rainfall. And this region, southern region, is closer to the equator, and therefore there are very humid sort of places. But as far as the Arabian Peninsula is concerned, as we all know, it is almost desertic and very dry sort of area. However, if you think about the water resources in the Middle East, what are the types? First of all, surface waters and rivers, of course, is very important. Another thing is the groundwater resources. It is also another second important source of water. And another one is also the desalination plants, which are not very much, common in many countries, but especially in Gulf countries, it is very common. So far as the rivers are concerned, the most important two rivers are Tigris and the Euphrates rivers, which I'm going to talk about them later on during a few slides. And on the other hand, in Sudan and Egypt and also, Eritrea, there's Nile River. These are the three very major rivers that provide water for hydroelectric energy generation, especially in Turkey, And another one is also agricultural activities and domestic use and so on, so forth. And these are the countries that we are going to concentrate on. Now let us look to why the Middle East is so important. It is important, politically it is important, geographically it is important, historically it is important, environmentally it is important, economics, oil, and now climate change and water resources. Especially if we think long terms, water resources will be more important than oil resources. That is one point. Another point is that, of course, the desalination techniques are very much used, as I mentioned, in the Gulf areas. But this, the water that we obtain from desalination techniques cannot be, potable. And I know that in these countries, they mix it with not very good groundwater resources. So the pure water from desalination is mixed with groundwater resources, so it becomes more usable. Another point is that, of course, among these countries, there are transboundary sort of countries, transboundary, rivers. Of course, we are thinking about rivers also only on the surface, but there are also transboundary groundwater resources. For instance, let me give you an example. In Saudi Arabia, Sag Aquifer, which is called in Jordan, DC Aquifer. And this groundwater resources is a sort of, a small problem between these two countries. So far as Turkey is concerned, of course, we concentrate on the Tigris and Euphrates River, but there are also groundwater. Therefore, it seems that there are some debates and conflicts between Middle East countries. Is it really true, or is it a sort of means to be used politically by countries that are far, far away from Middle East? That's another issue. Now, if you look at the meteorology and climate change impacts of the Middle East, especially the Eastern Mediterranean, which has been, said, or in reports of IPCC, it is the most potentially climate change impact effective areas. Therefore, Turkey has, of course, the coastal line with the Eastern Mediterranean, so is the Syria and Lebanon and other countries, Palestine, and also Egypt, and so on and so forth, including Cyprus. I'm not going to deal very much about this, air movements. So far as movements are concerned, of course, we have the northern air movement from Europe. It comes down to Arabian Peninsula during winter times. And also from the northeast, the Siberian sort of air movement. It also brings some sort of water, but very much important two sources air movements are. One is from India, monsoon sort of seasons, and another one is from Africa, which causes desertic area to have more desertic sort of features during especially summer and spring seasons. So far as the rainfall amounts are concerned, you can see it over there. But there is one part of Middle East which is very important. It is called Fertile Crescent. I will come to that point in some of the other slides. Now, of course, oil resources have a limited sort of horizon time-wise. Some resources as it will continue for about 150 years, 200 years, whatever the amount of years, it is known that there will be an end for this oil resources. But water resources are concerned, especially Turkey is concerned. Of course, hydroelectric power generation is very important for Turkey. And another point, are there any sort of artificial and natural alternatives? And for instance, if you ask my opinion, there is a rumor climate, seeding in order to increase the amount of rainfall. but I have been working in this part, and it is not convincing scientifically. Now let me go to another slide. World water balance, of course, this is very general sort of information, but the more important thing is that what happens in the Middle East. Look at this map. Now it is, focused, including Turkey and some important countries. Fertile Crescent. This has been very important. As you remember, in the past, there were many Sumerians and Babylonians, Assyrians, and many sort of civilizations. And they have contributed, agriculturally and also scientifically and many other activities. And it includes Palestine on the left-hand side, which is in the west, and also Kuwait and so on and so forth, we may say, Saudi Arabia in the south, and Turkey, my country, in the north. Now, let us look at a sort of simple drawing. We have Fertile Crescent. Okay, what are the things around this Fertile Crescent? In the north, we have water resources, as I mentioned, Tigris River and also Euphrates River. In the eastern part, oil reserves, you know what I mean. In the western part, holiness, a sort of religion frictions in a way. And in the south, we have drought, Arabian Peninsula. But let me tell you one thing. I think if there is an impact of climate change, the Arabian Peninsula countries will be very happy because the rainfall belts from the equator are going to shift towards north. So they are expecting to receive more rainfall and water resources in the perhaps 50 years or 60 years. Now let us look at the big picture. What are the water resources so far as surface water resources are concerned? Turkey has Euphrates and Tigris River, but shares this Euphrates River with Syria and then Iraq. Tigris River directly to Iraq. There is some very slight portion that is included Persia also. Let us look at the case of Lebanon, Orontes River, which originates from Lebanon. It goes through northwest, in northern direction. It goes through Syria and then enters Turkey and confluences with the Mediterranean Sea. In Syria, of course, is related with water resources in Palestine and also Jordan, and also, as I mentioned a little while ago, Iraq and Syria. And then onwards, from Palestine, there are two rivers which are very important, Jordan River and Benias River and Yarmouk River. These are very important, and they are carrying water from these countries to Israel. You see, and Haspani River from Lebanon. If you look at this picture, there are two countries which do not give any water resources outside of their boundaries, Iraq and Israel. Okay. Now, let me tell you one thing. So far as Palestine is concerned, of course, there are very rich sort of groundwater, but unfortunately, the Israelis, they don't allow Palestinians, which their right to pump groundwater, but they are restricted. But they themselves, these Israelis, they can pump as much as they like because nobody can tell them anything until recently. Now, after this presentation, short presentation, I have a couple of minutes, you see. There are recommendations and conclusions. of course, the best way of using water, that we have to be very careful about the water resources flexible usage, and must be controlled scientifically. There are many water resources management sort of procedures, and of course, among these countries, each one must respect mutually the rights of others. Another point is that, of course, each country, they have data. It may be meteorological data, hydrological data, and subsurface groundwater data, and so on and so forth. But unfortunately, among these countries, there is not a good sort of cooperation to share the data for regional sort of planning, which should be taken into consideration. And another thing is that there are transboundary sort of water resources, as I mentioned in the previous slide. And over there, with discussions, water resources issues must be, managed in an optimum manner, with taking into consideration each country's own internal sort of benefits. Not only that, also the neighbors. Water is a complex resource to manage, especially in the Middle East. It becomes a little bit more complex. If you ask my opinion, it will be rather simple, or very sort of, scientifically in right path, if each one of these countries who are the experts in water science, they come together and discuss. If we leave it to politicians, in that case, of course, there will be problems. Now, so far as the Middle East is concerned, like in many parts of the world, climate change is very effective. Population is increasing, and the already arid environments. So we have to be very careful about this desertification of some countries. Anyway, I think I have spent 15 minutes. Thank you very much for your listening. If there is any question, please, I'm ready to answer. Otherwise, I will expect the order from Abdullah Hamada.
Thank you very much, Hojam. Thank you very much. Perfect presentation. Anyone has any questions? Seems like no. So thank you very much again.
Thank you very much. So I completed my duty.
Yes, perfect. Perfectly.
Okay. So in that case, I say Allah'a ısmarladık. Ma'as-selame.
Ma'as-salam.
Okay.
Ma'as-salam.
Shukran. Thank you for everything.
Thank you very much.
Okay.
Thank you. Now I would like to move to our next presenter, Mr. Said Hussein. Are you ready? Can you please open up your camera and microphone and share with us your screen? Yes. Thank you. So Mr. Said is going to present the paper titled The Influence of the Mediterranean Climate on Interior Architecture based on Survey Environmental Climatic Conditions. Yes, Mr. Said, mic is yours. Please go ahead.
Greeting everyone. Hello, how are you, everybody? My title is talking about the influence of the Mediterranean climate and interior architecture based on severe environmental climatic condition. And my background of this paper is civilization have developed in part as a result of human interaction with the changing climatic condition of the Mediterranean, and this study emphasizes the importance of interior architecture and urban future. Purpose of this study. This purpose of this study is to understand the showcase and use insight into into the environmental characteristics of the Mediterranean effect of urban elements, and to develop the interior architecture layout on natural condition consisting of global Mediterranean cities based on the established criteria. So the methodology of this paper that I explained to you, a research method here describe a procedure to use to identify and analyze information regarding this study. Methodology consists first is a theoretical approach that for classifying and natural and human factor affecting that architecture and urban environment. Secondly, is to analyze of the characteristic of Mediterranean cities and to review the existing problems and benefits for their urban context and evaluate the architecture and urban consistency. So, to develop the criteria for producing an architecture and urban characteristic appropriate to natural and human environment. So, as we see this picture, it shows you that the classification of environmental elements affecting interior architecture and urban design. So, it shows that the human environment and the land natural and the climatic factor here that is the natural and human began consist components and affecting interior architecture and can be categorized so into the force of the natural environment and the effects of the human environment. So it's gonna be like facing the natural environment and the environmental factor. So it should be undertaking the land natural and the climate factor. Here, as we see the land natural, the architectural here identify of the land are effective factor in architecture and urban planning and environmental conditions were two of the most important factors in the design and construction. So it seemed that this diagram it shows the topography and the soil geology and geographical location, and each one it's followed for the each section. So the natural and human begin components for the natural land nature affecting interior architecture can be categorized. And here also to present this paper present investigate factor shaping for the each section for this section. So climatical factors, building here we use the building material that should be undertaken also and affect the indoor climate of building and the study looked at the impact of various building spatial design aspects such as building orientation, details or hang, shading, window and etc. So that means the solar radiation and temperature, wind direction, humidity, rainfall. Here, as we see in our method also on the materials, we talk about the human environment and the human environment, as we mentioned above, human factor include the social, economic, politic, culture, logistic, and technological factor. So, and we about the reflection of natural and human factor in the building. It's important to talk about it and the materials. So, building and urban settlement represent many features of the built environment. The building is mean the orientation, the form, dimension, room, walls, frontation, building material and construction, and the urban settlement, urban fabric, landscape and open areas, street and the pathways and the urban traffic. So this, as it shown you, our result, it's gonna be like the discussion. We showed that as in the table that how it should be and to taken into urban fabric, and urban level also for the all items, and the natural and human factor affecting architecture and urban design, and the reflection of these natural and human factor in the building, that urban design along with the natural characteristic of Mediterranean region formed the basis for the criteria of the design of architecture and built environment in the Mediterranean city. As we see in the present table here, these criteria that allow the evaluation of Mediterranean city, and it show the landscape and open space, open areas, and street direction and the pathways, that what should be the 40, as we see the angle from the picture, it should be 45 degree for the street, and normal natural here in the courtyard, how it's gonna be like undertaken. And here also we talk about the architecture style. Vernacular architecture is architecture to style concept, and we talk about the building orientation, how it should be from which side, and it made, and building form also we talk about it, how the surface area exposed to direct solar radiation, and the rectangle about it. And here is, as we see the level, architecture level, that the building size, wind direction, how the conclusion here for this paper shown that the Mediterranean city have one of the most unique and attractive architecture style in the world, and although the urban patterns of the Mediterranean cities and the process of creating a distinctive architecture pattern is considered a practical experiment represented by the elements and determinants of urban environment, with the result of a unique architectural characteristic as well as many natural and human factors and interaction between these factors based on the established criteria. Thank you for your attention, all our colleagues and the presenter, and that's my presentation. Anyone have a question? Otherwise, you can like go to get to Abdullah.
Thank you very much, Mr. Said. Anyone has any question for Mr. Said? Seems like no questions. Thank you very much again, Mr. Said. Now I would like to move to our next presenter, Mr. Ajiman Murad, going to be presenting the paper titled Sustainable Agriculture, Load-Based Smart Irrigation Systems.
Hello, everyone. I am Ajim Martaki. I am from Ghanaian University, CIS department. I am one of the authors of this paper, IoT-based smart irrigation systems, and I will be presenting. So the table of contents, we have the introduction, methodology, results, discussion, and conclusion. So for the introduction, as we know, agriculture faces a pressing challenge or pressing problem, which is meeting escalating water demands while trying to reducing irrigation volume. And also embracing sophisticated digital watering techniques has also emerged as a solution for sustainable and optimized resource utilization. Smart irrigation systems. They're acknowledged as critical in addressing water scarcity and wastage in agriculture. They also offer, or it also offers, empowerment to farmers through data decision making abilities. IoT, or Internet of Things in agriculture. IoT technologies occupy a central role in data collection, precision agriculture, and resource management. Sensors and data analytics enhance the efficiency and sustainability of farming practices. Now for the methodology of our paper. We employed the Prisma. We used the Prisma, or the preferred reporting items, for systematic reviews and meta-analysis selection approach, which is known for its visual depiction and systematic screening technique. Identification phase, that the identification showcase databases used as an initial article count. The systematic investigation or review was conducted between 2012 to March 2023 using key databases, which were IEEE Explore, Scopus, Science Direct, and Web of Science. The keyword query that was used across these databases were Smart AI and Smart AI, IoT, Web, and Irrigation to retrieve our studies. Selection criteria and process. The Prisma flow was used for selection, as mentioned earlier. So the initial identification from the databases were 4,567 papers, which were followed by the exclusion of duplicates and papers not meeting the exclusion and inclusion criteria, and following that, there was a thorough evaluation, which led to 33 studies, which met the inclusion criteria and which satisfied the authors to carry on the systematic literature review or investigation. Now for the results. We have the publication distribution by time frame and geographical locations. One, we have the temporal distribution. The study initiation. 2017 saw the inception or the start of field research on smart irrigation systems with IoT technologies. The research peaks, sharp increases in 2019 and 2021, which were possibly influenced by sensor industry advancements or technological advancements and post-pandemic adaptation. Meanwhile, there was a decrease of researches and developments in smart irrigation systems, which was potentially due to the global pandemic impacts. So 2023 is poised for increase in research, signaling the growing importance of agricultural systems. Geographical distribution. The very level of interest in smart irrigation systems across continents. For example, North America and Europe, they're moderate or low interest due to less water scarcity in agriculture. Meanwhile, South America and Africa, studies were limited because constrained technology, capacity, and high costs. Smart irrigation systems are expensive, and they require technological advancements. And South America and Africa are a bit behind in those two areas. And therefore, Middle East and Asia, they have higher interests, especially in some countries like India, Malaysia, Pakistan, and China, due to high population density and agriculture. So we can say smart irrigation, IoT-based smart irrigation systems are more developed, mostly developed, or there's more research done in them in Middle East and Asia. So the environmental factors in smart irrigation systems. One, we have the soil-related factors. Soil moisture, pH, nutrients are crucial in all the studies, meaning soil moisture and pH nutrients are crucial factors which is a must consider when doing research or when trying to develop a smart irrigation systems. Also, evaporation rates are vital in decision making, as mentioned in some studies. So weather or atmospheric conditions, temperature and humidity are prevalent. Also, wind speed aids accuracy. These are also important factors to consider whilst doing research in smart irrigation systems. And the geographic or topographic factors. We have solar radiation, earth slope, and drainage patterns. These are factors you should consider whilst these are environmental factors you should consider whilst doing research or trying to develop smart irrigation systems. So we have C, data collection technologies and analysis techniques. Technologies like Meslium Gateway, Force Interference Model, data clustering, CBR agents are key technologies that were used for the data collection across the studies by researchers. Various data analysis methods and tools were used, which included MATLAB, Python, IoT cloud platforms, machine learning algorithms. These are data analysis methods or tools used to analyze data gathered for the smart irrigation systems. So, achievement of smart irrigation systems. Positive impacts: reduction in water consumption, energy use, costs, labor associated with irrigation. Enhance agricultural productivity, crop quality, and better resource utilization through IoT-based data analysis and recommendations. These are positive impacts of the smart irrigation systems. So key findings in smart irrigation systems: reduction in water consumption by up to 95% in specific architectures, real-time monitoring, remote control capabilities leading to informed decisions and resource optimization, increased crop yield, flexibility, and convenience in irrigation management. Significant energy savings, improved water engagement, and reduced agricultural stress. These are key findings in smart irrigation systems. Also, precision agriculture through cloud-based IoT systems achieved a 48% reduction in water consumption and up to a 63% increase in crop yield. Overall, smart irrigation systems significantly contributes to water conservation, enhanced crop yields, and resource optimization in agriculture. So for the discussion, A, we have the importance of IoT-based smart irrigation systems. IoT addressing water scarcity and agricultural demands. This is crucial for managing resources amidst growing populations and water scarcity. Also, balancing increasing agricultural demands with limited resources also poses a challenge. The effectiveness of smart irrigation systems. Smart systems optimize irrigation, reducing water consumption and manual labor, maximizing water usage and minimizing manual efforts associated with traditional methods. Global distribution and applicability. Regional interest and challenges. As mentioned earlier, the interest across continents varies due to economic, environmental, and population density factors. Importance of smart irrigation systems in addressing specific regional challenges, such as water scarcity, high population density. These are challenges these are regional challenges and interests in smart irrigation systems. And also we have challenges and limitations. Cost and accessibility challenges. High implementation costs and limited accessibility in resource-constrained regions can hinder widespread adoption. So, yes, high implementation costs, limited accessibility in resources such as water, technological advancement, and geographic conditions. These are challenges that can hinder or can abrupt can stop the widespread of smart irrigation systems. Strategies posed to mitigate costs such were found out to be implementing micro pieces for efficient irrigation. So data accuracy and reliability. Ensuring data quality and reliability. Challenges in data accuracy and reliability addressed by incorporating diverse data gathering techniques and technologies. Potential solutions involving edge for cloud architecture and solar powered systems. Limitations of this study. This study limited coverage from specific databases and a defined time frame. Potential expansion of such scope should include more databases and diverse sources for comprehensive reviews. Recommendations for future research. Customization of systems to local requirements for soil, weather, and crop needs. Efforts to increase accessibility, affordability, and ensure data quality assurance. So for the conclusion, IoT-based smart irrigation system potential. Remarkable efficiency in conserving water, minimizing waste, and enhancing agricultural productivity. Critical factors for success. Emphasis on environmental considerations, varied data collection methods, advanced technologies, and renewable resources. Integration of sensors and cloud-based systems for data analysis, ensuring optimal crop yield without compromising soil or plant health. Need for continued research and collaboration. Ongoing research, collaboration among stakeholders, and knowledge sharing is crucial for further advancement and widespread adoption. Opportunities for future improvements and innovations in the field. So the contribution of this review. The review provides a comprehensive analysis of state-of-the-art practices, offers insights for practitioners, decision makers, and researchers regarding challenges and advantages associated with integrating these technologies in agriculture. This study also contributes valuable information for practitioners, policymakers, and researchers to foster development and adoption, identifying benefits and challenges, aids in guiding decisions for effective utilization of smart irrigation systems. Thank you all for listening. This is the end of my presentation. Thank you.
Thank you very much. Any questions? Okay, thank you very much. Since we have no questions, we would like to move to our next presentation. Ms. Firdaus going to be present the paper titled presenting the paper titled Urban Mining Applied to a Sustainable Building, a Reliable Solution for a Future Cities. Yes, Ms. Firdaus.
Hello everyone, my name is Firdevs Emine Sezer. I want to present my colleagues. I prepared this study with Irmak Öztürk, Zeynep Çetin, Associate Professor Gulçin Atılgan Türkmen, Professor Dr. Fatoş Germeli Babuna, and Associate Professor Murat Çakan. And our study's title is Urban Mining Applied to a Sustainable Building, a Reliable Solution for Future Cities. And I will talk about urban mining and urban mining index tool and our study's method, results, and conclusion. Ever-increasing activities of construction industry have reflections on resource depletion and other environmental impacts. The construction sector consumes 33% of resources and 20% of fresh water and causes 40% of solid waste. And the sector responsible for 37% of global emissions. The construction industry remains under immense pressure to reduce its material and climate-related impacts. These impacts, together with short lifetimes of buildings, emphasize the importance of urban mining activities applied to buildings. Urban mining is a crucial measure to improve resource efficiency that aims to maximize recycling rates in building materials in order to lower the environmental impacts of building construction. The objective of this study is to adopt urban mining to a sustainable building that designed for Solar Decathlon Europe 22 competition. The building is a detached house and it has a 84 square meter net living area, and prefabricated concrete is used for foundation. The building has 2 floors and 3 rooms, and straw is used for insulation, and all structure and windows, the doors are made from timber, and the lifetime of the building is 50 years, the claddings, plasters, and stiffing panels do not need additional painting or coating for reusability, and all wall and ceiling construction in the vertical extension follows the same dimensions for less the construction effort and the reusability, and all timber have high circular potential. Urban Mining Index tool is developed for the quantitative assessment of the recycling potential of the building structure and aims to keep building materials in as close cycles as possible. All components of our buildings, foundation, interior walls, exterior walls, and roof, integrated into the UMI tool. Based on literature research, comparisons, and several similar environmental product declarations of the building materials, material recycling content assumptions are made for our building components. The tool developed by Dr. Angie Rosen as part of her doctoral thesis at the University of Portal, and the first picture showed the tool homepage for foundation, and the right picture shows the closed loop potential and loop potential result graphs, and over the entire life cycle, all construction materials and all resulting valuable and waste materials are evaluated according to the quality levels of their subsequent use. In the post-use phase, sample capability is considered, the residual value of the materials after the construction and the effort required to extract them in monofractions at the end of their useful life are important. The recycled content are assumptions based on the literature studies and EPDs. The wood content, 30% internal wood downcycled and 30% recycled per use, and 40% downcycled in exterior wood and 40% downcycled wood used overall. For foundation concrete, assumption is recycling is 60% and 60% renewable post-use potential, and for timber, glue-laminated timber, 20% downcycled and 60% renewable, and insulation material, straw is 50% renewable, replaced with seagrass wood because of the straw isn't there's in the tool. Similar one is seagrass wool, and 50% assumed recycled. And for doors and windows, exterior doors are 20% reused and 10% recycled glass, and interior doors 30% reused and 10% recycled glass are used. And for cladding materials, clay is used, and clay has 40% recycled and 50% renewable post-use potential. For roof materials, roof windows has 30% recycled glass, and PVC frames 20% recycled and 50% renewable materials. And as the results, closed loop potential and loop potential of the components of the buildings are obtained, and in the foundation, due to highly recyclable steel, higher recycled materials and recyclable ratios are obtained. Due to solid wood, timber, and wood products in exterior walls, it is seen that higher renewable materials in pre-use and a considerable amount of energetically recyclable material potential. In interior walls, we see higher downcyclable material potentials. One reason for that might be their might be that there are no external effects on the water materials, especially in interior non-bearing walls and doors. In roof design, life cyclable materials for the post-use phase is again higher due to timber and coniferous wood and wood fiber insulation boards. The material type with the highest percentage in both closed loop potential and loop potential calculations during the pre-use phase for each component was downcycled materials. In the post-use phase, the material type with the highest percentage in closed-loop calculations for each component is energetically recyclable, fossil, or disposable. As a result of loop potential calculations, downcyclable and energetically recyclable renewable material types have the highest percentages. And also global warming potential are calculated in the tool, and the rule have the highest GVP result because of the main structural elements in bigger amounts at the roof, and the lowest GP value is from the interior walls. This is resulted from the emission factor of the glue-laminated timber. Wood products such as glue-laminated timber has a capability of intake carbon, therefore it provides reduction in GVP value. If we rank the GVP effects from low to high, the result would be interior foundation, exterior walls, and roof. Overall, the carbon footprint of the building is 18.6 ton carbon dioxide equivalent. The urban mining indicator is calculated as 59.6%. The urban mining indicator shows the circulatory rate of the building. We are able to progress to a much better point in the closed loop potential and loop potential values. However, energetically recyclable, fossil, or disposable and non-renewable materials, which stand out with high percentages in closed loop potentials, had a great impact on the result. Key achievement is sustainable climatrics compared to previous milestones and identified and addressed challenges in the circularity of materials, focusing on downcyclable and renewable alternatives. Urban mining insights provide a comprehensive view of resource efficiency and environmental impact in building design. These are our references used in this study. Thank you for listening.
Yes, thank you very much, Ms. Firdaus. Any questions? Okay. Since no questions, I would like to move to our next presenter, Mr. Ali Reza Burumi, that's going to be present the paper titled Smart City Synergy, Economic and Environmental Advantages via Microgrid, Smart Grid Integration. It seems like Mr. Ali Reza is having connection problem. Mr. Ali Reza, are you still with us? Okay, since Mr. Ali Reza seems to have an internet problem, we would like to move to our next presenter, Dr. Banagora, going to be presenting the paper titled Geographic Information System, Data of Groundwater Contamination and its impact on human health in Dilugad district in India. Dr. Banagora, are you ready? Okay, seems like we also lost Dr. Banagora here. So, Ms. Shivan, are you ready to present? Shivan,
yes, I am ready.
Okay.
I will show my screen.
Thank you very much. So, Mrs. Shivan is going to present the paper titled Natural Resources-Based Solutions for Water Management and Innovation Approach to Sustainable Design in Architecture, right?
Right. Can you see my screen?
Right now, no. Yes, loading, I think. Yes. Please, can you put it in reading mode, so we
Yes.
can see your, not view mode.
Okay. You can
Okay,
see
no.
now, right?
Yes, yeah. Thank you very
Okay.
much. You can-
Hello, my name is Şevin Dicle Binbir. I am doing my master degree in international water resources at İzmir High Technology. Today, I am here to discuss natural resources based solution for the water management and innovative approach to sustainable design in architecture. And water as a key element for life is extremely important for the global health. However, issues like a growing population, fast industrialization, and climate change are serious threats to water resources worldwide. Water scarcity caused by climate change, rising water demands, and unsustainable usage creates the problems for agriculture, energy productions, and providing drink water, especially in the dry regions and cities. And industrial waste, agricultural chemistry, and household waste pollute water sources, harming natural ecosystem and decrease its biodiversity. And climate change after the reputation partners increasing the risk taught on floods. This requires a reassessment and advancement of global water management strategy. Sustainable and water management needs effective policy and creation and implementation, collaborative efforts, and national and international
Excuse,
levels.
excuse me
Sorry,
for the interruption. Sorry very much for the interruption. If you can, please just move your camera a little bit down so we can see
it is
better.
okay
Yes,
now?
yes, much better. Thank you very much.
Okay.
Sorry for the interruption.
No problem. And water security involves ensuring clean drinking water and managing domestic and industrial use. Action to guarantee water security should be combined with the strategies to reduce social and economic inequality. And this part, let's explore the contributions of the water management strategies to sustainable architecture design. And rainwater harvesting can be used at different ways. Firstly, it can provide a clean water sources for the garden irrigation, where plants can naturally use the water. Initially, the collected rainwater can be used for toilets, flushing, helping to use clean drinking water more efficiently. It's also useful the cleaning process like washing building and recycle. And the gray water recycling means cleaning and reusing water from resources such as bathrooms, skins, and kitchens in households. Green water can be used in garden irrigation, toilet flushing, laundry, cleaning process, and soil irrigation. This method is employed to save water and reduce environmental impact. And however, safely measuring salt should be taken, and the water must be properly tried for the grey water use. And also, water efficiency landscape design and aim to use low water consuming plants. And now you can see some case study in İzmir Metropolitan Municipality Rainwater Reserving Project, and has a goal to save clean water for the future, making cities more resistant to climate change. This plans and 5,000 buildings in İzmir productivity dam with the special tanks for connecting the rainwater. These tanks can be used for activities such as watering gardens and cleaning and promoting of the culture of the connection rainwater thought of the city. And you can see when green roofs and rainwater harvesting system are used together, efficiently collection, storage, and utilization of water are maximizing, providing the sustainable thought, water efficiency, energy saving, proficiency of soil erosions, and environmental conservations. And also, materials with the low water density target water saving in the production and the processing process. And smart irrigation systems optimizing the watering process based on the actual needs of plants. They are using the agricultural also. And these are another example. This project, Vancouver Water Innovation Center, and this center integrates the various water management strategies such as rainwater harvesting, greywater recycle, energy efficiency, and water efficiency landscape design, and emphasizing sustainable architecture. And you can see the project details. And this project, 73% reduce in potable water consumption towards low volume flash and flow figures, and zero water heat pump system for the efficiency cooling and heating, and also underwater habitats secured, providing a new habitat for the marine species. And plants play a circular role in the effective utilization of the water, reduce water consumption, and mitigate environmental impacts. And also green roofs and walls promoted application of the plant-based design and absorb the rainwater, contributing to more efficient water use, and provide the environmental aesthetic and energy saving. And these are another case studies, and this project garden in Singapore. And this project served an enable example of the plant-based design, optimizing the water management towards plants and getting sustainable environmental impact. You can see the detail how they use it, the green walls and roofs and extra. And this is another case study in Singapore water reuse project. This project in Singapore is now worthwhile as a great example of managing water in sustainable way. They use advantageous methods like a membrane filtration, reserve osmosis, and ultraviolet disinfection to purify water. After treatment, the water is reduced for both industrial and household purposes. This helped making water use more sustainable by decreasing the needs for regular water sources, and to ensure people understand that the reclaimed water. This is a comprehensive education program. This program plays a circular role in gaining public support for reclaiming efforts. And overall, Singapore's new water project is a successful model for the sustainable water management and recycling water and education, the public and technology. And also, biofilm is known for its hydrophobic properties, reduce water absorption on the surface, and protecting structure. And biofilm can be integrated into the architectural design to enhance water management, especially on surface frequently in connect with the water and effective drainage. And ecologic balance, if we talk about this, biofilm is a natural occurring element in ecosystems and contributing ecosystem balance. And sustainable and energy saving in the biofilm can improve the water management by supporting the natural flow of water, ensuring efficiency use and contributing to energy saving, created from renewable resources or obtaining from recycling. Biofilm lines provide in the use of sustainable materials and reduce environmental impact. And if aesthetic on the architectural design in biofilm provided an aesthetic approach, and natural warning colors and texture create the architectural appearing results. And the technological innovation in the biofilm, more effective water management can be achieved by integrated with the smart building systems and environmental monitor technologies. And also, AI algorithms are essentially in planning smart cities, particularly in managing water. Architect can use the AI analysis capacities to create, design, the efficiently use water resources. This included the optimizing water description systems and the regulation water the consumption in the smart buildings. And also conservation the water is a key focus in architectural design. IA can design the incorporated water saving and like rainwater harvesting system and gray recycling. This integration has the potential to decrease the environmental impact of the architectural project actually. And using AI-supported design in green infrastructure and landscape projects help to manage water more precisely. The aim is to improve water absorption in the soil and reduce flood risks, aligning with the sustainable goals of the architectural project. And in the smart buildings, IA integration optimized water use taught algorithms, sensors and automated system regulated indoor water use actually affected the providing water conservation. And architects can really own IA quieting and choose eco-friendly materials and technologies. And this including the incorporating water saving technology and sustainable materials and circular parts of the architectural plans, working to minimize the environmental impact of the project. And finally, various technologies of sustainable architecture and water management, such as the rainwater harvesting and green roof, combined the efficiency water and used environmental sustainability. The increases of the official integration IA in the smart city design, architectural water conservation and the material selection further energize these efforts. Combining these approaches help address water connects, minimize environmental impacts, improve energy efficiency, and reduce water consumptions in the future architectural projects, and making the method circular for the sustainable and effective water resources management. And also thank you for the attention.
Thank you very much, Ms. Shivan. Nice presentation. Anyone has any questions? Okay, seems like no to me. Mr. Ali Reza is here, but I think he's having a connection problem. Okay, so what we can do about this? We can do nothing. So I think this is going to be the end of our presentation today, our session, our third session. Thank you very much for your attention. Thank you very much for your attendance. Then this is the end for our first session. See you in our fourth session after 15 minutes.
Hayat hızla akıyor ve biz bu hızı seviyoruz. Her güne heyecanla başlıyor, her anı doya doya yaşıyoruz. İlk günkü heyecanımızla yılları aşıyoruz. Zaman akarken biz de kendimizi arıyoruz. Heyecanla, merakla. Sen de kendini mi arıyorsun? O zaman zamana yetiş. Bu sadece kendini bulmakla ilgili değil. Asıl heyecan kendini yaratmakta. Bir şeyler mi yaratmak istiyorsun? Mükemmel. Metali işlemeyi, bir bina yapmayı, bir iş kurmayı, hatta bir şehir kurmayı öğren. Hayat kurtarmak, teknoloji geliştirmek, üretmek. Hepsi burada. Ve burada tüm deneyimler profesyonellerle yan yana. Ancak hızlı ilerlemeliyiz. Çünkü bugün şimdi gerçekleşiyor ve yarın çok yakın. Hayatta öne geçmek istiyorsan önce zamanın önüne geçeceksin. Hep ileri gideceksin. Bu Doktor Suat İrfan Günsel. Tanıyor musun? Onun da söylediği gibi. Üniversiteler toplumların dokuma tezgahıdır. Toplumları geliştirir, dönüştürür ve gelişmesini sağlar. O burayı bugünden yarına hazırlamak için kurdu. Senin için, ileriye gitmek için. Yana ya da geriye değil. Sadece ileri. Çünkü gelecek çok yakın. Hadi harekete geç. Fikirlerin ne kadar ileride olursa yarına o kadar yaklaşırsın. Yanındakileri de geleceğe taşırsın. Bu senin geleceğin, senin fırsatın şimdi. Hadi yarın yakın.